Okay, Derek leaves his physics book sitting on a drafting table that's inclined at 35 degrees above the horizontal. Free body diagram in figure 4-8 shows the forces acting on the book. This is page 132. Find the net external force acting on the book and determine whether or not the book will remain at rest in this position. So, I'm going to do the free body diagram in a couple different colors. So we have a force of friction on the book, and I'm going to erase the words book and table now, because you know what those things are. We have a force of friction on the book, F sub F of 11 newtons. We have a normal force on the book, we're told, of 18 newtons. And let me ask you this. Notice that the normal force is perpendicular to the surface of the table. Where's the force of gravity going to be without looking at the sample problem? Where?
Straight down.
Straight down towards the center of the earth. So normal force is not always completely in opposition to force of gravity. You got to be careful about that. Normal force opposes force of gravity. It's the force from whatever surface you're sitting on that's holding you up, but it is always perpendicular to whatever the surface is, and it's not always 100% in opposition to gravity. So we're told that the force of gravity on the book, F sub G, is 22 newtons. And this is F sub N. Okay, so we've got our three forces labeled. Oh, and they actually call that, because they haven't introduced the concept of normal force yet, they call that force of table on the book. By the time we get to section 3 in this chapter, you're going to know that that's normal force, so we're just going to skip the hoopla and call it normal force. Are you okay with that? Good. Okay, so, remember when we talked about assigning axes in problems? Where do you assign the x-axis? Where do you assign the y-axis? And we've got our good old traditional x-axis is parallel to the surface of the earth, y-axis is perpendicular to that. When you have problems with an inclined surface, the easiest thing to do is to tilt your axis to match the surface. That is the easiest thing to do. And later, I haven't done it this year, I've done it in years past. I'll run the analysis without tilting the axis, and it ends up being almost impossible to solve because there are factors. Anyway, I'll show you why later. The easiest thing to do, and this is the way the approach your book takes, is to say, okay, our x-axis is now the table surface, which makes our y-axis parallel to the normal force. Okay? So it's a little bit mind-boggling initially, but trust me, doesn't look like it. It is the easiest thing to do. So this leaves us, of our three forces, with two of them directly along axes. And that's the magic part. If we didn't tip the axis, we would only have one force that was directly along the axis, and that would give us more things that we had to resolve vectors for. This actually gives us fewer vectors that we have to resolve. The only vector we have to resolve is what? Gravity. We have to resolve that into its x and y components now. So we know that for this force of gravity, there is some f of g y, and there is some f of g x. And I'm going to make those little dotted lines. And I'll color code our f of g to correspond. Okay. These are terrible, terrible lines, but you'll just have to forgive me. So here's a question for you. What's that angle? Does anybody look at that and intuitively know what that angle is? You're going to get better at this, but we're gonna do a sort of a shortcut geometric proof on this. Okay. Ooh, that's a good approach. Let's get the calculator and see what that comes up with. 180 minus 90 minus 35. Not quite yet. I was going to say, that's not how I approach it, because I'm real visual, so I don't know if that one works.
90 minus that number.
So, minus 90? Well, okay, that gives us the correct magnitude. So, in essence, then, you're saying 360 minus, because 180 minus 90 minus 90, 360 minus 35, which gives you what?
Wait, what are we doing? 360 minus 35? Oh, gosh.
In terms of angles.
325?
If we've got a whole 360 and then we're subtracting, so we're back to 0, and we're subtracting 35, what do you have for your angle? You get negative 35. Okay, so let's do the visual geometric proof on this. So you're clearly probably more read-write because you're seeing it in numbers. I have to see it in pictures. So if we sort of transpose this out here, and we know that this is 35, and we know that that's our angle there, and we know that we have this, and these are not drawn anything approaching scale. So this is 35. If we extend this line, then we know that for this triangle, this is 90. This is 90 minus 35. And then if we take this angle...
Oh, goodness.
I know. What it works out to is that this is 35.
Yeah.
Okay?
After you draw it, it's not that bad.
Yeah, after you draw it, it's really not that terrible. So we know that this is, what, 55? Okay. Well, here we have another 90. If we look at this now smaller triangle, if this is 55 and that's 90, guess what that one is? 35. We're back to our 35. Okay. We can, if you're not comfortable with that, I can walk back through that with you slowly a couple times with more colors and a bigger picture. But for now, we're going to go ahead and move on, accepting that this angle is going to be equal to that angle. Okay? So, we'll walk back through it later. All right, so now we want to break up our force of gravity into the x and y components. Well, F of g y is going to equal what? Cosine of theta. F of g times cosine of theta. And F of gx is going to equal what? Sine. So F of g times sine theta. All right, now what we want to do is that sum of forces approach. We want to add up all our forces on the x-axis, all the forces on the y-axis. So if we do, sum of forces, we'll start with the x-axis, sum of forces on the x. What do we have? We've got force of friction plus F of gx. And we don't know that this is 0. That's kind of what we're looking at, is this thing going to slide down the table or not? Okay. And let's go ahead and just list our sum of forces on the y for now. We'll kind of do our little split. Move this over. So sum of forces on the y, we've got normal force plus F of gx. Now let me ask you this. Oh gosh, yeah. F of gy. Thank you. Do we know that these sum to 0? Yes. If the book is not floating up off the table surface or crashing through the table surface, then we know that the sum of forces on the y have to be 0. Okay, so what we know then is that F sub n is equal to the inverse or the negative of F of gy. Okay. That's resolved. That gets us our f of gy, and that means that there's no net force on the y, correct? Okay. Now let's deal with our x-axis. So, we're going to do this.
Does that say sum of fy equals 0? Or is that?
Sum of fy equals 0. Okay, so let's go ahead. Sum of forces on the x equals force of friction. Now let's plug in the expression that we've got for this. F of g times sine theta. Okay. I'm going to erase these. I think we know what those are now. So at this point, we're actually ready to go ahead and put numbers in. Force of friction is given to us as 11 newtons. You can do one of two things here. This would traditionally be the negative x direction. In this case, however, it's uphill. So you can opt for several things. And I'm not even going to look at how the book handles it because sometimes I don't like the way they handle those things. I'm going to go ahead and this is negative, and I'm going to keep this as a negative because we're going downhill, and it's force of gravity, which gives us a negative. So plus, well, what's the force of gravity here? 22 newtons, and we're going to say that that's negative 22 newtons times the sine of 35 degrees. So sum of forces on the x. Sine 35 times negative 22 plus 11. Okay. What do you get for sum of forces on the x?
Negative 12.618681.6.
That's what I get for this part of that. Did you add your 12 to it? Or your 11?
Oh, no.
Okay, do that. You got the right answer for the gravity on the x. What you got?
Me?
Yeah.
Negative 1.61868816.
Perfect. Okay, so is the book going to move?
Yes.
Yeah, it's going to slide right down the drafting table. Okay. And so if we sig fig this, we get 2 sig figs, so net force, sum of forces on the x is negative 1.6 newtons. Book will slide down the table. Okay.
Can you just use a squared plus b squared equals c squared on the bottom of the triangle since you know fy is the opposite of fn?
Yeah, you probably could.
And find like
The caution, I mean, it's actually more work. You know, because at that point you're having to do Pythagoras to get that. Yeah, you potentially could do that. Having not run that, I don't know if there's an error in it. I can't see one right off the top. Questions on this? So the big concept that I wanted you to see that I realized, we got to introduce, is this idea of tilting the axes. Anytime you've got something on an incline, this is going to be the easiest way to solve it. Because what it does, your normal force is always going to be perpendicular to the surface. Your force of friction is always going to be parallel to the surface. Gravity won't. So what that does is it takes two forces and has you then not having to resolve those into components. Questions, comments, concerns? Okay, I'll stop this video and then we'll do the angle derivation for number 5.